Hello, grade 9s. We're going to take a look at an activity today, and it's all going to be about performing operations with inequalities. So we're going to test out some addition, subtraction, multiplication, division, all of that. In front of you right now, you should have either a mini whiteboard and a whiteboard marker, or a loose leaf and a pencil. For this activity, you don't have to keep whatever work we end up doing, but you do need to have something in front of you to follow along with it, okay? Now, the first thing I need you to do is I need you to come up with 3 inequalities. Those inequalities can be whatever you want, any number in the whole entire world that you choose to involve in your inequalities, totally cool. They should use only greater than or less than symbols, no or equal to for this activity. Okay, so there's no inclusion in that inequality. An example that I have here that I've chosen is -3 is less than 10. I want your 3 examples to be different than what I have on the screen. But pause the video, come up with 3, check that your partners are accurate, they're correct. And then once you've done that, restart the video. Okay. Hopefully you restarted the video. I'm also going to come up with 3 inequalities. So my first one is -3 is less than 10. You already saw that one. I'm going to come up with 5 is greater than 2. And I'm going to come up with 9 is less than, 15. Now, those 3 inequalities that you've written down, we're going to use throughout the entire activity. Now, your inequalities are likely different than my inequalities, especially the first one. You should not have this one. You should have something that's unique. And your inequalities will likely be different than the person's next to you. Now, we're going to perform operations on these inequalities, and depending on the numbers you chose, you might have some really easy math to do. Depending on the numbers you've chosen, you might also have some pretty complex math to do. If you've chosen some ridiculous numbers, don't change them, but you're welcome to use a calculator just because the point isn't to be able to do mental math. The point is just to see what happens when we do operations with inequalities. Okay? So, what we're going to do is we're going to explore how different operations impact the inequalities. We're going to look at those 3 inequalities that you've chosen. We're going to do a whole bunch of things to them. I'm going to tell you what to do, and we're going to see what happens. Now, at the end of each thing that we do to each inequality, I want you to ask yourself, is this statement still true? And if so, great. And if not, I just want you to think about it and be like, interesting. And then we'll move on. So the first thing I want you to do is to each of your 3 original inequalities, I want you to add 3 to both sides. So I'll do this first one with you here, just so that you totally know exactly what I'm doing. So I'm adding 3 to both sides, which means for my first inequality, I end up with 0 is less than 13. For the next one, I add 3 to both sides. I get 8 is greater than 5. And if I add 3 to the last one to both sides, I get 12 is less than 18. So that is what I want you to do for each of your 3 inequalities. I want you to add 3 to both sides. Once you've done that, I want you to assess how accurate it is. My 3 all ended up being accurate, which is great for me. The next thing I want you to do is do the same idea, add 2.5 to both sides. Are your inequalities still true? And once you've done that to all 3 of your inequalities, I want you to try adding -2 to both sides and see if your inequalities are still true. Pause the video, give it a go. Welcome back. Oh my gosh, it's been so long. Okay, so when I've added 3 to both sides of my inequalities, I'm finding that all of my inequalities remain true. That's pretty great. And if I try adding 2.5 to both sides, I should also find that nothing really changes. What about adding a negative? Did anyone figure out if adding a negative changed things? So if I add -2, I add -2, If I add -2, I get -5 on the left for my first inequality. And I get +8 on the right. And yeah, -5 is still less than +8. And hopefully you found that for addition, all of these statements remained true. Yeah, the numbers change. But adding to both sides of an inequality does not impact the validity of that inequality. All right. Next here, we're going to do the same thing except this time with subtraction. So with your 3 inequalities, I want you to subtract 2 from both sides. See if that remains true. Once you've done that to all 3, subtract 4/3 from both sides. Do that to all 3. And then subtract -10 from both sides. Do that to all 3. I want you to talk to your partner and say, hey, did you find anything change about your inequality, about your validity of your inequality after you subtracted the same number from both sides? Pause the video, give it a go. And welcome back. So I'm going to try subtracting 2 from both sides here. I'm going to do that to all 3 of my inequalities I've chosen. And for the first one, I get -5 is less than 8, which is still accurate. For the second one, I get 3 is greater than 0, still accurate. And the last one, I get 7 is less than 13, still accurate. And no matter what, oops, that wasn't an eraser. No matter what I do, whether I'm subtracting a positive number, subtracting a fraction, or subtracting a negative, I should find out that my inequalities still stay true if I'm subtracting any kind of number on both sides of that inequality. So whether I'm subtracting a positive, a negative, a fraction, doesn't matter. I should get my final inequality to remain true. Let's try things with multiplication. Whoa, changing it up. So, and for this one, I have 5 different numbers that I want you to try multiplying both sides by. Can you, right now, with your inequalities, try multiplying both sides by 5? See if your inequality stays true. Then multiply both sides by 5 halves. Does that still stay true? Then multiply both sides by -2, and then multiply both sides by -10. For all 4 of these examples, I want you to see if when multiplying both sides by the same number, if my inequality stays true. Pause the video, give it a go, come back when you're done. Oh, welcome back. Okay, so I'm going to start by multiplying both sides by 5. And I get -15 is less than 50. Seems legit to me. Times both sides by 5. I get 25 is greater than 10. Yeah, happy with that. Multiply both sides by 5 here. And I get 45 is less than 75. Yeah, it is. So when I multiply both sides by a +5, I was so fine with that. And now, if I did the same thing, except with 5, instead of 5, I'm multiplying by 5 over 2, I should end up with actually really similar numbers, except now everything's divided by 2 at the end. So if I did this with a calculator, I might get a decimal value, and that's totally cool. But if I take a look at the first one, I end up with -7.5 is less than 25. Yeah, that's true. The second one, I get 12.5 is greater than 5. Still true. The last one, I get 22.5 is less than, what is this, 37.5. And yeah, that's also true. So when I multiply both sides by whether it be 5 or 5 halves, I noticed my inequalities stayed true. Hopefully you also found that. Realistically, I know that you chose different inequalities than I did at the start, and that's cool. You're your own person. You have your own thoughts. But hopefully you're finding the same conclusion that I'm finding. If you're finding something different, double check your operations. Now what I want to do is I want to try multiplying both sides by -2. see what happens with that one. So for the first one, I get 6 is less than negative 20. Hold up. That's not true. Okay, what about the next one? If I multiply both sides by negative 2, I get 5 times negative 2 is negative 10 is greater than negative 4. Hold on, that one's not true either. Okay, what if I multiply the last one both sides by negative 2? I got negative 18 is less than negative 30? No. Okay. So we were all good when we were multiplying both sides by a positive, but now we're multiplying both sides by a negative, and my inequality is no longer accurate. It's almost as if I flipped the sign, everything would have been okay, right? It's always telling me a wrong answer. I wish the inequality was flipped, but it's not. What if we did that with the negative 10? Am I still getting answers that are also wrong? I mean, you've tried it, so hopefully you know the answer. But if I'm multiplying both sides of my inequality by negative 10, here I get 30 is less than negative 100. Hold on, that's wrong too. What about the second one? I get negative 50 is greater than negative 20. That's also wrong. And negative 9 times negative 10 is negative 90 is less than negative 150. Okay, so something weird is happening when I'm talking about multiplying by a negative. Because multiplying by a positive we were cool with, but every single time I multiply both sides of my inequality by a negative number, all of my signs are in the wrong direction. Like if I had those numbers individually, I wouldn't put the sign that way. I'd flip the direction of it. Okay, noted. Addition, fine. Subtraction, fine. Multiplication's a little bit weird. Well, we've got one more operation, and that operation's division. So I'd like you to try dividing both sides by the numbers here. So try dividing both sides by 2. Try dividing both sides by 0.15. Again, you're welcome to use a calculator. Divide both sides by negative 5. Divide both sides by negative 1. See what we get. And go. And welcome back. Okay. Hopefully you've come up with your own conclusions here already. But let's just try a few of them. If I'm dividing both sides by 2, I end up with negative 1/2 is less than 5. Okay, seems fine. I'm okay with this so far. My next one, I get 5/2, or 2.5, is greater than 1. Okay, world's feeling all right now. Dividing both sides by 2. I really wish at the beginning of this I chose more even numbers, but here I am, can't predict the future. And I get 4.5 is less than 7.5. That's pretty good. And I should be able to get similar answers, not answers in terms of the numbers, but similar outcomes of my inequality remaining true if I divided both sides by 0.15. Those positives should still work out. Let's talk about those negatives, because the negatives gave us trouble last time. Will they give us trouble now? One way to find out. So, if I divided both sides by negative 5, I get positive 3/5 or positive 0.6, if I remember my fraction decimal conversion, is less than negative 2. That is wrong. In the next one, I divide by negative 5 on both sides. I get negative 1 is greater than negative 2/5, which is negative 1 is greater than negative 0.4. That's also wrong. And what if I get positive 9 divided by negative 5? Well, when I do that, I have 9/5, so negative 9/5, or negative 1 4/5. Yes, I'm sneaking in fraction review. Okay, and when I do that, I get negative 1.8. And on the other side, I get negative 3 3. And that is also wrong. Okay, so we've gone through all 4 of our basic operations. And there's 2 situations where I have inequalities that when I do that operation to both sides, my inequality statement is invalid. It is not true. It does not satisfy the statement. So, here's the big takeaway. The big takeaway is this. When we add to both sides of an inequality, cool, nothing bad happens, stays the same. We're living our best lives. It's great. When we subtract the same amount from both sides of an inequality, it remains true. We're living our best lives. It's great. It's awesome. Nothing changes. When we multiply, as long as it's by a positive, inequality stays true. We're happy. We're great. And when we divide, as long as it's by a positive, it remains true. It's great. It's fantastic. Now, the big difference is here is that when we multiply both sides by a negative, that inequality isn't true. But to make it true, we want to flip the direction of the sign. And when I divide both sides of an equality by a negative number, again, that wasn't true unless we flip the direction of the sign. Now, this is going to come into play in a huge way when we start solving inequalities. And when I mean solving inequalities, I'm just going to give you a little taste of what's to come. Okay? I'm talking about like solving an equation like this. We know how to solve an equation like this. We've done it before. We divide both sides by positive 2, and we get x is equal to 5. We're going to do that now, except with inequalities. So I might give you something like 2x is less than 10. And you divide both sides by a positive 2. And because I divided both sides by a positive, my inequality is cool. It stays the same, doesn't change direction, remains true. Life is good. But we're going to get to a point where I might have a similar question, but this time when I'm solving for x, I might have to divide both sides by a negative number. And we just discovered that when we divide both sides by a negative number, that inequality does not stay true unless we flip the direction of the sign. So this here is the big difference between solving inequalities and solving equations, is that in an equal sign, both sides are equal to each other. It doesn't matter the order that I say it, they're the same. But in an inequality, the order really matters. And this plays a huge role when performing operations to both sides of an inequality. And that's where we're going to see it moving forward. All right. Thanks for playing along today. You guys were great. Please make sure you put your supplies away, and I'll see you next class. Bye.